So hello everyone, welcome back to the video. First of all, very happy Independence Day to you all. So sorry I got late today because of the flag hoisting. So let's start with our video and let's see the problem. So today we're going to see problem number 342, that is power of 4. Okay. So you might have noticed we have seen couple of similar problems, right? The power of 2, power of 3, and similarly we have seen now power of 4. So given an integer n, return true if it is a power of 4, otherwise return false. So it's the same thing we need to find if it's a power of 4 or not. Power of 4 will be 4 raised to x, will be anything, and we need to find if we are getting n. Okay, so here we are giving n equal to 16, that is true. N equal to 5 will not get it, so it is a false. And n equal to 1, it is also true because 4 raised to 0 will be 1. Okay, the constant are also same, like in minus 2 raised to 31 to n, and it's an integer, so it's integer constant. And there is also a follow-up. Could you please solve it without loops and recursion? Okay, so first we'll see, try to solve it with loop. So we're gonna find an approach. Okay, we will do one thing, we will make all the possible power of force and check it if it equal to n or not. Okay, so that's a simple approach we are going to do. So let's start coding, and the current will take it equal to 1. Initially we'll keep it 1 because 4 of 0, 4 is to 0 will be 1. And while the number does not overflow, so means current is greater than 0. Okay, greater than 0, we'll check if current is equal to n. If they become n, we will return true. Okay, and so if not, current equal to current into 4, we'll keep on multiplying it by 4, and we will find all the numbers that is power 4, and we'll just compare with n. So a simple logic we are doing here. And if we did not get any number, any such numbers, so we'll return false. Okay, so here we have completed our code, so let's try to run it. Okay, and it's working completely fine. So let's go to description. There they have mentioned something like follow up. Could you solve it without loops and recursion? Okay, so we'll try to solve it without loops and recursion. Okay, so let's go to a compiler. Okay, and I will print here all the power of force. Okay, just for the reference. So you can see it, this is 4 is to 0, 4 is to 1, 1, 4, 16, a little bit zoom in. Okay, 64 to 56, we have it. Okay, and we can see these are all power of 2 also. If you remember, like 2 raised to 2, it is 4, 2 raised to 4, it is 16. Similarly, they are all power of 2, that I can see it. Okay, so let's see their binary representation also. Okay, below them. Okay, for 1 it will be 1, for 4 it will be like 0, 0, 1, and for 16 it will be like this. So you can see every single number have only a single bit. So it can be said like it's a power of 2, right? Yeah. So we'll comment this. Okay, we comment the number and see only the binary representation now. We're trying to find a pattern if we get it. Okay, then we'll see here it is only 1. Okay, here it is 4, this is 16. So if you can see a pattern in this, every time for every number, two zeros are added. Okay, you can see here 20 is adding, and the first number is odd, correct? The second, the binary representation bit is on the odd position. I'm telling that. So this is also an odd position. This is 1 is odd, 3 is odd, 5, 7, 9. You can say. So okay, so we can conclude this. So we can say if a number is power of 4, the first condition it should be positive. Okay, these all numbers are positive. Second thing, it should be a power of 2 because we can see only one bit is set in this all numbers. And third thing, it should be an odd position. The bit should be in odd position because suppose we take 8, right? 8 also we represent like this 1, 2, 4, 8, correct? So 8 will be represented like this, barabar. But is 8 is a power of 4? No, it is a power of 2, correct? So, but because it is an even position, right? So we can see 1, 2, 3, 4. It is an even position. So it's not an power of 4. Okay, so we need to find such numbers. Okay, so we'll write some conditions for it. Okay, so we'll go to the code and write some conditions. So I'll just remove this. Okay, we'll write a return. First condition was the number should be positive and n should be greater than 0. Next condition was n should be power of 2. So if you don't know how to find a power of 2 in without the loops, you can go to my power of 2 video and see it. So it's simple. We are just doing n. I'll just put this in and n minus 1, and this should be equal to 0. If we don't get it 0, means there is another bit set and it's not a power of 2. And the third thing we need to find is, okay, we get it like the number is positive also, number have only one bit set, but it is in odd number or not. Okay, so for that there is a hex code. Okay, we will find a binary number which will give us all the bit set in the odd positions. Okay, so here I've kept the number actually ready. Okay, I will explain you how we get this. Okay, and this and n should not be equal to 0, because if it is 0, then the bit is set in the even position. Okay, and we'll try to run this. Okay, we get it. And okay, so another representation of this is by hexing. Okay, we can use hex code here like 0x. This represent hex. Okay, in hex we can say 1 decimal. Okay, 4 decimal equal to 1x. Okay, so we'll write what numbers gives us a combination of odd number. Okay, a 4 binary representation number. Okay, now we'll see 1, 2, 4, 8. So we want every bit in the odd position to be set. So what gives us that? So we'll see a 5. Okay, so here 1 will be set, here 1 will be set, here 0 will be there, and 0 will be there. So this is a perfect number that we want. Okay, here 5 will be set. Okay, so in hex we will be adding it like this, like 5. So how many bits we have? 4 divide 32 divided by 4, we'll get 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 times it will make like this 0, 1, 0, 1, 0, 1, 0, 1, and we'll get a 32-bit number, and that is equal to this number which I have written here. So I'll just comment it down and write it. Okay, and try to run it. Okay. So this is also working. I'll just show you by submitting it, and I will show you this difference in the compiler so you get it clear how we are doing. So here the time complexity is big of 1. Okay, and space also big of 1. Okay, so let's go to the compiler and I will take this number and I will show you. I'll just remove this while loop. Yeah, this also, this part also. So first I will show you this number representation. Okay, in binary representation of, you can see every odd bit is set in this number. Okay, now this is not an idea that I will get or you will get by intuitions. Okay, you need to do a practice, you need to do a lot of practice and understand the pattern. So until you don't write the problem, write on the page or do something and try to find a pattern in that, like how I did now. Okay, then we have to find this number. To find this number, so I have used hex, so I will just write hex here. So 0x is the hex representation and 5 I am writing it. Okay, and I will run it. Okay, so you can see it's showing me 5 representation. If I just add one more 5, okay, so this will give me number like this. Okay, 0, 1, 0, 1, and again same 4 bits to the left of it, 0, 1, 0, 1. Okay, so whatever the number will be, we'll try to run and see. Okay, see, we are getting the same thing which I showed. So, and if we just want to see the value of that, I can show you that also. So it's more clear in your head. I don't want to make this video long, but just explaining how I got this one. Okay, so it's 85 and the binary. So in this way, I want how many pairs of 4 to make a 32 bit. So I want 8. So I'll just add more 6 fives. Okay, and run it. So this becomes my same number. And okay, I have not put here the binary representation. I will just copy this here. Okay, okay, so you got it. You can see every odd bit is set, and we are just doing an AND with n, so that if the bits matches, then we can say it's the power of 4. So hope you liked the video. Hope I explained it well, because I was not that prepared today. So thank you for watching the video, and if you have any doubt, if you don't understand what is hex, what is decimal or bit, please comment down. I will try to help you and make you understand this. Thank you.